Hello, my dear friends. I hope you're fine. In the previous video, we made an HTML structure and we did some styling. So our page is ready to be integrated with JavaScript, and we would love to add functionality. But before that, we need to cover some very important topics because we have to understand what morphing is before we start coding how to achieve this. So for that, I have prepared a very short kind of a slide, and I would like that we hopefully understand what is morphing and how it works. So basically, we know that what morphing looks like. We basically try to blend one shape into another shape. And in SVG, as we know that there are path, there is a very powerful attribute called path, and in path each point is stored and its different properties are stored along with it, so that a path can be interpreted as a one continuous curve, and this curve basically needs to be converted into another curve. That's what morphing really is. So for that, we first of all we should have two curves. So like in this example, we as we can see that in the center there is one curve. This curve has some points, and it has some offsets from other curve. The other curve is a straight line, and if we assume that both have same number of points at same y positions, then we can see that both curves have some offsets. The curve number A, which is black, I would call it A, and the one which is in gray is called uh, curve B. So from A to B, we have to first of all sample points. As you know that a line and a curve can potentially have infinite number of points. So to sample points, we have to specify the number of samples. So the more the samples, the better the result, and the finer we would be able to capture the details. If we keep our sample sizes small, then we would not be able to capture much details. To see this in action, let me show you quickly what I mean. So here, let me share the screen. So in this example, we see that we want to basically approximate area under a curve. This is not exactly same what I'm trying to tell you, but it is very similar idea. So for that, if we use one rectangle, then there would be some loss of area here, and it won't fit the shape. Then we would gradually add more and more rectangles or bars, and slowly and gradually the area approximation would be much better. This is exactly same case with SVGs, morphing and sampling. If we take more samples, then our curve transition from one curve to another would be very smooth. So then what we do, after taking the samples should be equal. That's very important because the number of samples that we are taking from one curve should always match with the same number of samples that we are taking from another curve. So that's an important point step. So suppose we have specified 1,000 samples, then we should take 1,000 samples from curve A and then from curve B. Then what would we do? We would match them one by one, and we would calculate their horizontal and vertical offsets. For example, this is point's location in curve A, and then it should be and the similar point one by one-on-one mapping. We see that its position in curve B. So there is a difference between them. There is an offset. So we calculate that offset by subtracting relative coordinates. X2 minus x1 would be an offset in x direction. Y2 minus y1 would be an offset in other direction. So after calculating these offsets, we perform LERP or linear interpolation. Linear interpolation is a very important concept in a lot of programming. In a lot of use cases in programming, we come across linear interpolation. It's a very powerful tool. We should at least know about it, and especially if you like to work with games and game development, you should know linear interpolation. So linear interpolation is a very simple function. It ensures that there is a parameter, an arbitrary parameter t, which is zero, which goes from 0 to 1. And we set t such that when t's value is 0, then it is in curve A. When t's value is 1, then the point should be in curve B. And this is a very simple function, a plus t multiplied by b minus a, which gives us basically how to interpolate between two curves or any 2 points in space or any. This is basically saying that if you want to move one point from A point to B point, then how should it work? And in between, it gives us basically steps to animate it as well. Okay, so in case of our calculations in our curves, as we have a 2D shape, so this formula would just transform into x1 and y1's new positions. So in case of x1, we would just multiply it by, we would add x1's current position with the difference between x2 and x1 multiplied by t. This t will actually help it to move towards a particular endpoint. So then we can also see that how the timing should work. Let's try to understand that. Timing means how much time would it take from one shape to could be converted into another shape. So we can specify a particular time. For example, we want this to be this particular curve to be morphed into the second curve in suppose 2 or 3 seconds. I have made this time very large to just see how these things work in action. So we have to specify a time, and then how does that timing work? For example, how does t scale from 0 to 1 in that particular time? For example, we have specified 3 seconds, or maybe 4 seconds, or maybe less time. For example, we have specified t into our time as 200 milliseconds. So how does t always scale from 0 to 1? So for that, there is a very simple formula. And we would also see what is an easing function. Easing function is all about how the our it's all about the speed of our animation, how our animation looks and feels like. For example, if we simply interpolate t from 0 to 1 and give it the increments in a regular intervals like 0.1 increment on each frame, then it would be very linear. The time between any two frames would be always be uniform, and it would move in a very straight forward way. Uh, so if we want to give some life to animation, then there are other easing functions which ensure that t always remains from 0 to 1, but in between the frames, the difference between frames can be greater or lesser depending on what easing function we choose. We would look into easing functions in detail as well. So let me give you an idea of how these things come into play, and we would also see that we have seen these two balls, the pinkish ball and the bluish ball. So they both have their destination set, and we have already given a uniform time for all the animations to complete in 3 seconds. So even if the distance is less, they would or the distance is more, they would always start and finish at the same time. This is very important. And similarly, we have also used these arbitrary shapes, and we have also given some very simple morphs to these shapes, and we would see that these all of the elements that are placed on this particular frame would always start and end at the same point. So let's look at this example. As we can see that each and every thing, there are a lot of things going on. So let's go back. And first of all, let's observe this curve only. So we can see that this curve slowly this point moves from this offset to the center, and this is all happening based on these equations, and t will go from 0 to 1. As this function is mathematical, and we can calculate t from 0 to 1, we can also do the reverse. So when we do the reverse, then it starts from 1 and it goes back to 0. We can do that as well. So this is the powerful usage of linear interpolation, which helps us in solving these kinds of problems. And right now there is one easing function also applied, which we can't actually tell right now. But in Adobe XD, we have some options available. So we have selected ease out function. So this actually means that animation will start slow, then in the middle it would be a bit faster, and then at the end it would be slow again. So if we just closely observe this ball, we can see this effect. It will start slow, then it fast, then it slows down again. So this is one example of an easing function. So let's also see some other examples of easing functions I would show you. And also about the timing, how the timing should work. So basically, to make this always smooth, and to ensure that t will always be 0 to 1, we basically scale the timestamps and their difference by the total duration. We have a start time. Start time means that whenever or the first frame of our animation is called, we record the time. Then after that, we continuously get the time. Okay, what is the current time right now? Then we subtract our starting time from that. So we get a difference between those two times, and we divide it by total duration. For example, we have specified 3 seconds duration, so we would always divide that. So whenever, no matter how much time is passed, the t will always be from 0 to 1. So this will make our animations time bound. Basically, we can change our duration, and the animation would still work. It would automatically speed up or slow down depending on our time. So this is a very nice technique, and we would use that in our next video as well, when when we are actually coding it in JavaScript. And now let's see how easing functions work. And we would there is a very nice resource online which I found. I would share that with you. So let me get back to the browser. Okay, so here basically we have some easing functions. I would share this link in the description as well. This link basically gives us a little bit idea about the easing functions. So basically, this is what I'm talking about, ease in and out, and but there are also mathematical functions applied to it, sine wave, quad function, exponential function, and some back in and out function. So these curves basically control how animation flows. So if you observe that at start there is relatively less change, then in the middle there are sudden jumps, and then in the end there are also slow changes. So this is also reflected in this animation. Okay, so next we have also some, this is a very linear function, which we have already seen that t is uniformly increasing from 0 to 1, and each difference between each frame is same. So these are basically some other cubic Bezier functions. So we actually apply a Bezier curve, and we can see that how it works. And this is actually a classical example of ease in and out. As we can see the gear turning, we can see that in the middle it turns a bit faster, and in start and end it turns a bit slow. So this is the kind of a very natural effect, and it's mostly used in most of the animations. Ease in and out actually gives some life to the animations. So this is one of those functions that we use, and there are many types of function, exponential functions, circular functions, back and forth functions. So these are very Various different types of easing functions. If you are interested in that, I would share this link, and you can see how easing function works. So let's get back and see if there is anything left. So by using these techniques, we can actually make wonderful things. For example, let's get back to the first frame. We can morph any shape into any shape. And also there was a question asked in our first video by a very capable and nice viewer. He asked that is it necessary that both shapes have the same number of points? So it's absolutely not necessary. We can have any two different shapes, and both can have any number of points. The only thing that we need uniform is number of samples. We have to sample them basically with the same number. For example, if we are using 1,000 samples from curve 1 and 1,000 samples for curve 2, these are all we need. And then we would perform linear interpolation. Then we can make anything into anything. For example, if we play this animation again, we can see that this star can morph into a square. And it also translating as well. It is moving from one place to another. And we also have literally transformed this line segment into a circle. So we can do all sorts of things if we understand and grasp how morphing works. So that's it for this part. This was to just give you a brief overview of what are we going to do and what is morphing. And it was very important that we understand this concept, because this will help us a lot in coding and preparing us for what's coming next in our JavaScript code. So thanks for watching. And if you have any questions, please do ask in the comments, and stay tuned for next part.